It's the final nugget on subnetting. Woohoo! At least for now. Two big topics to cover. Number one, reverse engineering subnet masks, which is actually the most common form of subnetting, but thankfully also the easiest. And then the pinnacle of all subnetting knowledge, subnetting based on variable length subnet mask requirements. Let's start off with reverse engineering a subnet mask. So here's the scenario. You have a router on the customer prem or in the service provider network or any device, right? And you see it have an IP address and a subnet mask. And the questions could abound is that a valid IP address? Is it part of the right network range? Is it, again, there could be a whole gamut of things right or wrong with this IP address, but this isn't nice and pretty like the previous nuggets where we had the requirements based on hosts or networks, and I said, okay, we've got step one, find the number, convert it to binary. Step two, determine your subnet mask and find the increment, right? Or reserve bits in the mask and find your increment. And then step three was to find the network ranges. Sorry, the lines represent things that I don't want to write all over again. It's everything that we talked about in the previous nuggets. Well, what do you do with this? There's no quote unquote requirements. Well, the key is they've essentially given you the answer, right? What was the whole goal behind these three steps? Well, it was to figure out what subnet mask you needed and then get the increment, which would tell you what network ranges you have. Well, what they've done here is they've essentially given you the answer or started you halfway through step two. They said, here is the custom subnet mask that somebody figured out at some point in their life based on network or host requirements. So now it's essentially the question is, can you pick up in the middle? Can you, if you were given the subnet mask in step two, could you figure out the increment and determine the network ranges to figure out if this really is a valid IP address or is in the right network or things like that? The answer is absolutely. All you have to do is convert this mask to binary. Now, all of these are all ones, right? So we're really only concerned with the last network bit, right? Or this last octet. So we could say all ones, 1, 1, 1, 1, up to 1, 1, 1. That's what 224 is if we converted it to binary, 0, 0, 0, 0, 0, right? So the lowest network bit in this subnet mask was a 32. So now we can jump straight down to step 3 from the last couple nuggets. Use this increment to find the network ranges. Well, at some point when they were figuring out subnets, they would have had to start from 192.168.1.0, right? And then we just say, okay, well, let's kind of do their process. 32, 64, 96, 128, and I can stop right there, right? Because I passed the IP address that I was looking for. So now I just need to fill in the ranges. I don't even have to go all these, 31, 63, 95, and this is through 127. Okay, ding, 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 ding. Anyone see what's wrong with this picture? It's like Highlights magazine for kids, right? There's an elephant on the screen. You can't. So what's wrong with this picture? You can't assign that IP address to a host. It's a what? Broadcast IP address. It's the last one of the network ranges which you can't use. So the only way you would know that is to be able to reverse engineer it. Let's do another one, and this is far more test-like. I wanted to, throw out something, I shouldn't even say test-like. I would say real-world-like. You see this all over the place, where host A, and it would be buried in some other bigger scenario, so it wouldn't be quite so focused as to this would be the only problem. But host A can't surf the net, or can't access file shares, or fill in problem that host A cannot do right here. And you look and you go, okay, well his IP address is .65. Subnet mask, default gateway is .62, and I look and I go, okay, well, default, that lines up with what the router is. Looks good, right? Well, let's break it down. Let's see the subnet mask. This in binary is a whole bunch of ones, for those first 3 octets. Dot, and then .240, 1, 2, 3, 4, 0, 0, 0, 0. And trust me, after you do, there's only 8 values it could be, right? So after you do this a long time, you will just, it's like the Matrix where, remember that scene, the original Matrix movie where he's looking at the code going down, and he's like, I don't even see the code. He just, interprets the code. He knows what the code means. So same kind of thing. So this lowest network bit is converted back to decimal, a 16. Now, let me do this, and then I'll give you a shortcut. At some point, they would have been at 172.16.68.0, as they're subnetting, .16, .32, .48. See what I'm doing? I'm just counting by that increment. dot 64 dot what would that be, 80, 96, et cetera, et cetera. But I've already passed the IP address. Okay, well, let's fill in the end ranges. This goes through 15. Does anyone see the problem already? 63, 79. What's the problem? This is the first valid IP address in this range, 172.16.68.64 through 79. It is valid. It's the first usable IP address in this range. But the problem is the default gateway is the last valid. Again, it is valid, but it's in a different subnet. Last valid IP address in this range. The .62 is the one right before the broadcast. They are in different networks. Even though they're plugged into the same switch, which is implied by that picture, they're plugged in the same thing. They've actually been assigned to two different networks. And I'll tell you what. Doesn't matter if you have a crossover cable going between these two devices directly. It doesn't matter if they're plugged in the same switch. If they're on two different networks, meaning at a layer 3 perspective, they won't be able to reach each other. This guy will say, okay, well, to get to my default gateway, I need to go to a default gateway because it's on a different network than me. That doesn't work. Now, okay, computers allow you to be messy sometimes. They might use something called proxy. I mean, maybe it would work, maybe, but it probably won't. Okay, and it's just, if nothing more, it's just a horrific design. So, but again, looking at this, hang on, back out for a second. Look at this. Imagine all my chicken scratch isn't on the screen. Do you see a problem with this picture? I don't. I mean, it's 65 isn't that far from 62. I mean, they look close. It looks like a normal situation. Okay. Second thing I want to bring up here, and I was going to mention this earlier. Some of you might have recognized very astutely that is a Class B address. So they would say, well, you can't start from 172.16.68.0. You would have to start, since it's Class B, from 172.16.0.0, right? Well, I guess maybe, technically, but you would be counting by 16s for a long time. 32, you'd go all the way down until you reach 256, which is an increment of 16. I mean, these are all powers of 2, right? So they all add up to the same thing eventually. And then you go to 1.0 and 16, all the way down, until eventually you got to 68. So if you want to fill up, a good notebook full of paper with incrementings by 16, you can't. So the reason I bring that up is because there's sometimes, I mean, let's just say, you've got an IP address that instead of 65, which isn't too bad to be able to reach if you're counting by 16, maybe the IP address is .236, right, is the IP address there. Well, if you're counting by 16, you're kind of like, ugh, I don't want to 32, 48, and somewhere around 48, I'm going, I'm trying to do the math because it's not something I do. That would be, so I'm struggling trying to remember what numbers it would be, much less going past 100 and so on. So how can I just kind of jump there? Well, a couple things. One, you can always start from 256 and count backwards. Subtract 16. Remember, 256 being, the very, 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 very end. So it would be .240 would be counting backwards by 16. Then we'd go to 224, right? And so we could work our way backwards to reach a number like this. And again, counting backwards as the start of the range. Or what I like to do is I realize that all these are increments of each other, right? If I count by 16s, will I eventually get to 32? Yes. If I count by 16s, will I eventually get to 64? Yes. If I count by 16s, will I eventually get to 128? Yes. So what you can do is you can actually use this knowledge to your advantage. You can take some big jumps when you're counting. You might start from 172.16.68.0, right? But then you can say, well, if I've got to get to 236, maybe I'll throw on a 128 as my next one, because I know 128 is one of my powers of 2, and I know if I count by 16, I'll eventually get there, right? So I can go ... 128, and then I can say, well, I'm still pretty far off, so maybe I'll add on a 64. So 128 plus 64 is 2, carry the 1. If my penmanship wasn't so messy, 192, right? So 192, and I'm a whole lot closer than counting by 16s all the way to 192, and then maybe I add on a 32, right? You see what I'm doing here? I can use these guys to do some big additions instead of all the small additions, or maybe once you get here, you just keep counting by 16s until you finally reach the network range for .236. So again, a nice way that you can save some time and save some increments. I can imagine having an increment of 4 or 8 and then having to count all the way to 236. It would be painful without knowing you could make these big jumps. Now we come to the second big topic of subnetting, and what I would call the pinnacle of subnetting knowledge, variable length subnet masking. VLSM, in a nutshell, simply means changing your subnet mask whenever and wherever you want to meet your custom requirements. Up till now, we've been trying to find one subnet mask to rule them all. So for example, when I say I need 30 hosts per network, then we find one subnet mask and find all these different network ranges, right? Or maybe I say I need 10 networks. Again, one subnet mask, find all the network ranges. Well, I know some of you, as you were looking at the network scenarios, said, well, it'd be kind of nice if I could find different ones. For example, I've got a network of 20 users and then another network of 60 users. And then these networks, the WAN links, how many quote-unquote users do they have? I know some of you might be, well, none at all. Well, actually, there are two, one on this side and one on this side, right? That's the IP addresses on each end of the connection. So always two host addresses, if you will, per network on the WAN link. So can we find different subnet masks to meet those requirements? The answer is yes. And so here's the kind of scenario that you might see approaching this. It says subnet 192.168.1.0 to address this network. Use, and here's the key, the most efficient addressing possible. Efficient. That should echo in your mind when you hear efficient, because finding one subnet mask to rule them all might be efficient for the 60 users, but wouldn't be efficient for these guys. As a matter of fact, I can tell you, just flat out wouldn't work. If we found a subnet mask to reach 60 users, it would be the same one that earlier in actually the last nugget when we looked at the host, it would be the same one that we used to reach 50 users. It was 255. Well, I don't want to give it away, but essentially you would only get 4 subnets if you used a 60 user subnet mask, and that would address this one, and maybe this one, but then you've got 2 subnets that you can't address. So let's see VLSM. Step 1 is to, and this is, I will say, here's the big secret to efficient VLSM, and then I'll add some caveats or some best practices at the end. Start with the biggest network first. Now, what's the biggest network in this picture? Okay, 60 users, right? So here's our 3 steps. Step 1, let me put the binary chart up here, 128, 64, all the way down to 1. So step 1 is going to be take the number of hosts and convert it to binary, right? This is our second flavor of simple subnetting based on the host requirements. And I'll say, okay, converted to binary. Okay, there's our first one. So I know that to get 60 users, it's going to take 6 bits, right? So step 2 is to write the subnet mask, the original subnet mask, in all binary. And we can start shortcutting it. So I know it's going to be 24.1. So I'll just do, can I just quickly abbreviate those? That's my 24 ones dot 1, 2, 3, 4, 5, 6, 7, 8. What we start with, that doesn't really matter to write that out because we can't change it. The zeros are really our playground. So I'm going to say, okay, I need to, am I creating more networks, or am I saving the hosts in this picture? Save the host. 1, 2, 3, 4, 5, 6 have to be saved in order to get my 60 users or 60 IP addresses. The other 2 flip over to the network side. So we go to a /26, or if we want a decimal, it'd be 255, 192 would be the last octet of the subnet mask. But I'm going to stick to this CIDR notation. It's just quicker to write. And my increment, if I underline that, will be a 64, right? Which gives me a warm fuzzy to see 64 as an increment if I have 60 users. So I'll go 192.168.1.0, 192.168.1.64. Now hang on one second. How many networks of 60 do I need? Just one. Right? I'm looking, there's my, I've got it right there through 63. That's the end IP address. There is my network that I can assign there. So I'm going to write it on this 192.168.1.0 through 63 / what would this be? /26 is the subnet mask, right? That's what I found out right there. Now, keep in mind, this is Jeremy's way of writing it. Normally, in the quote-unquote real world, people would just put 192.168.1.0 /26, but I like having that number there so I can quickly see it. So if I'm filling out a network diagram, that's all I do. Now, the fun part about VLSM is now you get to do it all over again. Seriously. I know, you're like, really? Really? So what's our next biggest subnet? 20 users, right? So I'm going to do 20 users. How many bits to get the number 20? Well, let's scribble this out. Our first one goes right there, so it's going to take 5 bits to get the number 20. Our original subnet mask is a /24, and I'm still going back to the original. I'm not going with this. It's like as if I started over up to a certain point. So I've got my 24 ones, 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? And I'm saving the host because it's 20 users. So I'm going to say, let's go with the red color. 1, 2, 3, 4, 5 get saved. The other 3 flip over to the network side. I'm now a /27 or 255.255.255.224 as the subnet mask. My increment is now a 32, right? So step 3, finding those network ranges, I'm going to do 192.168.1.0.32. Now hang on a second as I keep going down. Can I use any of these? 0 through 31, 32 through 63? The answer is no, because they overlap with my network right here. Now, remembering that these powers of 2 are all increments of each other, essentially, the shortcut is I just look where this one left off, and that's where I start incrementing from. So I'd say 64, okay, 96, 128. Now, how many networks of 32 did I need? 2, right? One for that side, one for this side. So I'll do 64 through 95 and 96 through 127. And there we go. I've got it. So let me write those up here. There we go. They're now showing. Now remember, if you're in a certification exam environment, they may ask you to do some variant thereof. And what I mean is I wrote the actual networks under each one of these sites, but they may say, well, we want you for this. I mean, you might be wondering, how would they even ask a question like this on a certification exam? It would be drag and drop. Essentially they would have subnets or they would have IP addresses, and you would drag and drop them on the diagram to the places that they would go to kind of complete the answer to the question. So it may say, you may have these big boxes right here where you have to, from a big multiple choice box list, take, 192.168.1.65 from a list and kind of drag and drop it to complete the network diagram, if you will. So it may be saying, actually assign an IP address, don't just identify the network. But essentially, it's same kind of concept, right? So are we done here? No, we are not. We still have to go in and do the WAN links. Those are subnets as well. WAN links are subnets too. So I'm going to box this off down here. How many hosts on a WAN link? 2 hosts, right? How many bits to get that? 2 bits. Your 1 goes right there. So 2 bits to get 2 hosts. Can't do it with any less. Step 2, /24 is our original mask. Whole bunch of ones. 1, 2, 3, 4, 5, 6, 7, 8 zeros. So I'm saving the host. 1, 2 remain hosts. 1, 2, 3, 4, 5, 6. I'm going really fast, so hopefully you're hanging with me. You've seen a number of examples. This is now a /30. Our increment goes to a 4. Right? So step 3, finding our network ranges, 192.168.1. Okay, I'm not going to count by 4 from 0 all the way up because I can't use all those up to 128. If I counted by 4s, I would eventually reach 128, 132, 136, 140. Now, how many networks of 2 do I need? 2 hosts? 3, right? 3 WAN links. 1, 2, 3. So fill in these end ranges, 131, 135, 139, and there you go. Without rewriting them, I would go up here and assign these with a /30 mask at the end of them to each one of the WAN links. And there we go. That is VLSM in all its glory. Now, a couple caveats, as I promised, best practices. It's amazing when you look at this to say, wow, we just barely went over the halfway point of the subnet and we've addressed the whole network, whereas if we had to pick one subnet mask based on the biggest, we would come up short. We wouldn't have been able to do this if we could only use one subnet mask to rule them all. Is this a good practice? Kind of. I would say the knowledge of VLSM is good, but doing it this tight, like you're seeing on the screen, can be problematic. What happens when this office goes through a hiring spurt, or this one, the biggest subnet at the very beginning of the range right here, goes through a hiring spurt and brings on 10 more people? Well, it just went up to 70 users, which now doesn't fit in the subnet that you've allocated, and now there's no room for growth, right? You have to, start getting really ugly and either scratch the whole thing and start all over, which nobody would want to do. I mean, changing subnets at a site is brutal. I mean, think about static IPs assigned to servers, to printers, to wireless access points. You're going manually to all these devices to change them. It's not pretty. So what you would normally want to do is leave room for growth, right? Or set up VLANs or something. So, I mean, something to where you're not doing this so tight that you bottle it in. So the skill of VLSM is very good, especially when you have maybe you do, you know, /24s, excuse me, or even /23s on all the LANs. This is the one that gives you 510 hosts per subnet. And then you just use VLSM to address the WAN links efficiently and give those two addresses there. I've seen a good best practice where a lot of times you do your subnetting, you might do all these custom subnets as we did before, but when you get to the WAN links, instead of picking up where the subnets left off, the user subnets, you actually start from the end of the range. So again, remember on the last slide, start from that 256 and start working your way backwards, like 252, 248, you know, using that increment of 4 down. So essentially, the WAN links come from the bottom of the range up, and the user subnets start from the top of the range down, and you kind of meet in the middle, so you don't end up boxing yourself in with all these tiny little WAN links along the way. So that's another best practice that you can use. But again, while this looks so pretty on paper, is it a good practice? No, it's not good to pigeonhole yourself that tight with all of these subnets. I now deem you subnetting masters. Seriously, we've gone through 3 nuggets now that has taken you from 0 to hero in the subnetting world. So first off, I want to make sure you know that's fast. It can take people days, if not weeks, to really feel good about subnetting. So I don't want to shortcut any processes. If there's anything within you that makes you go, well, I think I kind of, anything like that at all, please don't go on in the series. This is something that service providers use day in and day out. It is a daily activity in the service provider network, so it is hugely important to you. So please practice. Go through the homework exercises again. You know, search online for some more examples. There are literally thousands of them available for free online. So make sure that this is one that really feels good to you before you go on. I hope this has been informative for you, and I'd like to thank you for viewing.